To work out the length of a line on a graph where you have two coordinates, this is the formula that you're going to use. D, meaning distance, is the square root of the change in x squared plus the change in y squared. That's it. So let's say you had this portion of graph, x1, y1, x2, y2. You're going to use that formula to work out the distance or the length. So let's use that to work out this question. The straight line L1 with equation 4x minus y equals 0 and the straight line L2 with the equation 2x plus 3y minus 21 equals 0 intersect at point A. Work out the coordinates of A. So the equation of L1 we can rearrange into y equals 4x. And then we can sub it in 2x plus 3 times 4x minus 21 equals 0. Can you finish this off? Can you work out the coordinates of A, please? So you should have gotten 2x plus 12x minus 21 equals 0. 14 x equals 21, x equals 3 over 2. When you sub that into y equals 4x, y equals 6. So that is your coordinates of A. 3 over 2, 6. Okay, that's part A. Part B. Work out the area of triangle AOB, where B is the point where L2 meets the axis. O means origin, so the point 0, 0. And you're trying to find the point where B is the point where L2 meets the x-axis. L2 meets the x-axis means the y-coordinate is going to be 0. Okay, so we take L2 and we sub in y equals 0. Like that. So our 2x is going to be equal to 21. X equals 21 over 2. Okay. If we were to draw a triangle, then this point here will be 0, 0. This will be 21 over 2, 0. And this would be 3 over 2, 6. To work out the area of a triangle, we do half base height. The base is 21 over 2. The height is 6. Times those together, 63 over 2. Okay, so that is the form in which you might get some sort of question, or the format that a question can come in. Quite wordy, a little confusing, but I hope that made sense. So, can you pause the video and try question 11, please? Okay, part A. Work out the equation for straight line L1. We're going to do the same thing that we've done previously. We're going to start off by working out the gradient. Your x2 and y2 is going to be s. Because if you notice, s is higher up in the graph compared to r. So your gradient is y2 minus y1 over x2 minus x1. So 0 minus minus 2 is 2. 9 minus 5 is 4, so a half. Sub that into your y minus y1 blah 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 equation. So y minus minus 2 equals a half x minus 5. Y plus 2 equals a half x minus 5 over 2. So y equals a half x minus 9 over 2. Cool. The straight line L2 is perpendicular to L1 and passes through the point R. Work out the equation for the straight line L2. Perpendicular. So the gradient of L1 is a half. So what's the gradient of L2 going to be? The negative reciprocal. So minus 2. And they said it passes through the point R, which has the coordinates 5 minus 2. Y minus minus 2 equals minus 2 times x minus 5. Y plus 2 equals minus 2x plus 10. Y equals minus 2x plus 8. There we go. Write down the coordinates of t. T is the y-intercept of L2. So, using the equation which you just worked out, what's going to be your y-intercept? 8. So t has the coordinate 0, 8. Okay, part D. Work out the lengths of RS and TR, leaving your answer in the form k root 5. So it's going to be some sort of surd, and the number inside that surd is going to be 5. Okay, working with RS, we're going to use the equation x2 minus x1 squared, so your change in x squared, plus y2 minus y1 squared, your change in y squared. So that's going to be 9 minus 5 squared plus 0 minus minus 2 squared, which is the same as 4 squared plus 2 squared, which is root 20, which is root 4 times root 5 to root 5. Okay, that's RS. We also want TR. Using the same formula, subbing in your values, 5 minus 0 all squared plus minus 2 minus 8 all squared, which gives you 5 squared plus minus 10 squared, which is 25 plus 100, root 125, which is the same as 5 root 5. Okay. Work out the area of RST. Okay. Looking at the graph, that bit in green, that's our RST. Meaning this is our base, RS, and TR is our height. And to work out the area, we do a half times the base times height. So a half times 2 root 5 times 5 root 5, which gives us 25. There we go, done. That's how you use the length formula, and that's how you can work out the area of a triangle using coordinates, using lengths and straight lines.